Semiconductor Concepts, a summary of semiconductor theory. Valence band and conduction band. Valence band. The valence band is the outermost electron shell of an atom. Conduction band. The conduction band is the energy band outside the valence band, holding electrons that had received enough energy to leave the valence band. Intrinsic and extrinsic semiconductor. Intrinsic semiconductor. Intrinsic semiconductor is pure semiconductor such as pure silicon or germanium. Extrinsic semiconductor. Extrinsic semiconductor is pure semiconductor such as silicon or germanium that has added impurity atom. Doping. Covalent bonds. Covalent bonds hold atoms together in semiconductor material. Each atom is bonded to 4 adjacent atoms. Doping. In addition, the addition of impurity atoms into the crystal structure of semiconductor material is called doping. Doping may be done with pentavalent atoms or trivalent atoms. Doping with pentavalent atoms. Doping with pentavalent atoms produces N-type material. If a pentavalent atom is introduced into the structure of pure silicon, each pentavalent atom bonds with 4 silicon atoms, leaving a spare electron that can go into the conduction band. Doping with trivalent atoms. If a trivalent atom is introduced into the structure of pure silicon, it bonds with only 3 other adjacent silicon atoms, leaving the 4th adjacent silicon atom with a missing or absent electron. The absence of an electron is called a hole. Doping with trivalent atoms produces p-type material. Depletion region and potential barrier. Depletion region. A depletion region void of charge carriers is formed when free electrons from an adjacent N-type material diffuses into p-type material. The free electrons fills, in quotation mark, holes in the p-type material in a process called recombination. This results in the N-type region having fixed positive charges and the p-type region having fixed negative charges. These fixed positive and negative charges cannot, I repeat, cannot conduct electricity. Hence, the area across the p-n junction is called the depletion region. The area is depleted of charge carriers. Potential barrier. The fixed charges in the depletion region opposes further movement of electrons from the N-type side to the p-type side. A potential barrier is thus set up across the junction. For a silicon p-n junction, this barrier is approximately 0.7 volts. It is approximately 0.3 volts for germanium. The p-n junction diode. The diode. A p-n junction is called a p-n junction diode or simply a diode. A one-way street to current. A diode allows current in only one direction. Leakage current. Although a diode allows current in only one direction, there is, however, a small current in the opposite direction due to minority charge carriers. The current is called leakage current. Leakage current thus results from the flow of minority charge carriers. Forward and reverse bias. Forward bias. When the positive supply is connected to the anode of a diode and the negative supply to its cathode, the diode is said to be forward bias. The diode conducts when forward bias. Reverse bias. When the positive supply is connected to the cathode of a diode and the negative supply to the anode, the diode is said to be reverse bias. There is no current when in the reverse bias except for a small leakage current.